Before we jump into the assertion, it is basic to see the value in what enormous Hadron Collider LHC work by. CERN is a 17M ring of superconducting magnets and the world's greatest and most strong atom smasher. It addresses the peak of human logical accomplishment. It's strong to such an extent that it would be able reproduce the physical as a matter of fact states of the universe's introduction to the world. Yet could this machine intended to open the universe's secret hold the way to something undeniably more dismal? CERN, laid out in 1954, is one of the world's most regarded research associations with 23 part states and huge number of researchers. It fills in as a center point for cooperation and development. The LHC is CERN's leader project. However, it's just a single piece of a tremendous organization of gas pedals and tests. Envision a circuit not really for vehicles or ponies, but rather for subatomic particles dashing against the very texture of reality. The LHC speeds up protons to almost the speed of light, sending them on an impact course that impersonates the energy of the universe at the hour of the enormous detonation. These impacts make temperatures a large number of times more sweltering than the sun's center. A large number of magnets guide the protons on their excursion, while cutting-edge cooling frameworks keep the magnets at temperatures colder than space. The bars inside the LHC are made to crash at for focuses around the gas pedal ring, comparing to the areas of four molecule identifiers mapbook CMS Alice and LHCb. Each fills a special need, investigating various parts of molecule material science. Together they go about as titanic cameras catching depictions of these impacts. Researchers then filter through the flotsam and jetsam looking for hints of the subtle Higgs boson, otherwise called the God molecule, and different peculiarities that proposition pieces of information to the IV's basic structure blocks. By concentrating on the microcosm we gain bits of knowledge into the universe, yet with each answer comes another inquiry, and with every revelation another test. The LHC isn't simply a logical instrument, it's a demonstration of human interest and creativity. It epitomizes our tireless quest for information and our craving to grasp the principal powers that shape our universe. Anyway, as we put the limits of what we realize, we should additionally consider the moral and existential inquiries that emerge. What are the dangers of examining the unexplored world? Could our mission for understanding incidentally release powers past our control in the consecrated corridors of CERN, where the restrictions of human getting it are continually tried? A disclosure has arisen that sends a shudder down the spine of even the most prepared researchers. Brian Cox, a previous scientist at CERN and a regarded voice in molecule physical science, as of late made a proclamation that has left the world both intrigued and frightened. Cox's words reverberate with tormenting lucidity. The objective of CERN's huge Hadron Collider is to reproduce a smaller than usual enormous detonation. For sure you heard that right, limited scale form of the very occasion that brought forth our universe. The physicists happen to make sense of the ramifications of this objective, featuring the LHC's exceptional potential for historic revelations. These incorporate opening the secrets of the Higgs boson and exploring dim matter, a strange substance that is a critical piece of the universe. Envision outfitting the force of creation itself, the capacity to take advantage of the actual substance of the universe. It's an appealing possibility, yet one full of risk. The idea of a smaller than normal large bang is definitely not a hypothetical thought. It's a substantial reality inside the LHC. The temperatures, tensions, and crude energy produced in the collider mirror the states of the universe's early stages. It's like remaining at the beginning of written history, seeing the introduction of presence itself, yet with such power comes liability and an inquiry. Looms consider the possibility that something turns out badly. In 1978, Russian physicist Anatoly Bugorsky encountered a frightening occurrence that always transformed himself while working on the U-70 synchron at the Organization for High-Energy Physical Science and Russia. A breakdown Kaus's head to incidentally come into direct contact with a proton bar. The shaft with unbelievable power went through his skull, entering the rear of his head and leaving through his nose. Borsky's experience was phenomenal. He saw a streak more splendid than 1,000 suns, yet had no worries. The shaft's way left a trail of obliteration, consuming tissue and bone, yet he stayed cognizant and even strolled to the center for treat. The consequence was both alarming and interesting. The pillar caused confined tissue passing, prompting hearing misfortune in one ear and incomplete facial loss of motion. Incredibly, Borsky's scholarly capacities stayed in salvageable shape, and he proceeded with his logical profession. This episode isn't simply an individual misfortune, however, a wake-up call highlighting the huge power and possible risk of molecule gas pedals. The dangers of a molecule collider like the LHC are not to be messed with. The potential for unanticipated responses, the control of the actual texture of reality. These are not the stuff of sci-fi, however certifiable concerns voiced by some in the academic local area, quite possibly of the most chilling and convincing worries related with the LHC's examinations is the chance of making a minute dark opening. Dark openings are locales of space-time where gravity is so solid that not even light can escape. They are vast vacuum cleaners, devourers of stars and cryptic elements hiding in the shadows of our universe. Might the LHC at any point make such a peculiarity, even for a little scope? Could this dark opening develop, wildly consuming the Earth from inside? Researchers at CERN have guaranteed the public that any dark opening made would be shaky and would dissipate right away. Anyway, the slim chance has started discusses fears and a feeling of wonder at the power we use. Understanding how the LHC could make a dark opening includes digging into the mechanics of molecule gas pedals. When protons crash at almost the speed of light, the energy delivered is colossal to the point that it twists the texture of space-time itself. Envision a firmly extended trampoline, and afterward a weighty item is dropped onto it. The texture twists and contorts. If the weight is weighty enough, it could make a wretchedness so profound that anything close by would be brought into it. This is a short-sighted similarity for what could happen in the LHC in the domain of quantum physical science, where the universe's standards are both peculiar and lovely. There exists a hypothesis that additional aspects might be secret inside our universe. If these aspects exist, the LHC's impacts could take advantage of them, making a gravitational channel that frames a minute dark opening. This multifaceted dance of particles has even drawn the consideration of a portion of the world's most famous researchers, especially the late Stephen Selling, in his works Selling caution of a situation where the Higgs boson could become unsound at very high energy levels. This shakiness could set off what is known as a horrendous vacuum rod, an enormous occasion that wouldn't just obliterate Earth, however, could demolish the whole universe. Such a significant change, he contended, ought to provide us opportunity to stop and think and energize smart reflection. The stakes are impossibly high and the edge for mistake is razor flimsy. Analysts at CERN are very much aware of these worries. They have determined probabilities, run reenactments, and examine speculations to guarantee the security of the LHC. Brian Cox himself has recognized the significance of capable exploration, perceiving the far and wide feelings of dread and concerns. Encompassing the LHC's exercises, he underlined that thorough well-being measures, comprehensive surveys, and careful conventions are set up to guarantee the LHC's tasks are led with the extreme attention to detail. Cox consoled general society that the energies associated with LHC tests are well inside the scope of what the Earth normally experiences. Moreover, he noticed that the possibilities of making a steady dark opening are cosmically low regardless of whether one were shaped. Researchers declare it would be so little and temperamental that it would quickly scatter into energy, a peculiarity anticipated by peddling and known as peddling radiation. It would be a transient snapshot of enormous marvel, a brief look into the pit, and afterward gone. Still, hypothesis endures. Some propose that the LHC's test could open a entrance to another universe or aspect, while standard science generally excuses such cases. The thought has caught the public creative mind, igniting interest, dread, and even legends. The idea of equal aspects isn't new. In material science, string hypothesis, a main competitor for a bound-together hypothesis of everything, recommends that there might be more than the natural three aspects of space and one of time. These extra aspects could be compactified or stowed away from our discernment, however, could hypothetically be gotten to or uncovered under outrageous conditions. Currently envision the LHC as a vast key opening entryways that have been fixed starting from the beginning of recorded history. When protons crash at extraordinary energies, they could in principle make swells in the texture of space-time, possibly uncovering stowed-away aspects, while established researchers remains suspicious of such thrilling cases. The more extensive thought of molecule gas pedals opening the universe's mysteries has driven to more extensive public interest in the expected dangers and outcomes of such tests. As we dive further into these strange regions, it is vital for balance our mission for information with a level-headed thought of the moral and existential dilemmas we face. The LHC's trials might be a demonstration of human resourcefulness, however they additionally help us to remember the tremendous power we use and the obligation that comes with it. One of the most interesting and questionable thoughts connected to